everyone, welcome to the video. Today I want to discuss the potential of XAI in mental health care. Now see, mental health issues are global with conditions like depression and anxiety impacting millions. While machine learning models have made strides in predicting and analyzing mental health conditions, they often operate as black boxes, leaving healthcare professionals in the dark about how decisions are made. This is where explainable AI comes in. The primary focus of XAI in mental health care is transparency. Using techniques like line and shape, we can understand the reasoning behind predictions. These insights aren't just technical, they have real world implication. To explain all this, I have created this PPT. So let us go through the PPT. Now, the first page is the content page which I have created for my reference. Now, let us go through the introduction part. I have already given you guys the introduction of our project on the first slide itself. So, these are just points which you can go through to recall what I said. Now comes the objective parts. The objective of integrating XAI into mental health care are clear. Firstly, it is to predict conditions like depression and anxiety with accuracy, to identify key health features affecting mental well being, and most importantly, to make predictions understandable for both doctors and patients. Our findings reveal significant improvements in decision making and resource allocation when XAI is applied. Now, here comes the literature review. These are the 4 papers that helped us create this project. You can also go through these papers. These are already available online. Now here comes the methodology part. The first step of our methodology is obviously importing libraries and load healthcare dataset, which is obvious for any project. Then we have applied feature engineering to handle missing values and manage outliers. Then we have trained the models, which includes decision tree model, random forest model, XGBoost, etc. And lastly, we have used line and shape for transparent results. Now, let us go forward. Now, here comes the results or findings. See, if you guys are wondering how this data came, we have already included the link of our project in the description below. In the first picture, we have all the 4 performance evaluation matrices for our all 5 models. In the second picture, we have the feature importance for each model. Here we can see that in XGBoost, gender played an important role, while in AdaBoost, losing someone played an important role, and so on. Now, on the right side, we have feature and value for the single data point that is under examination. Now, in the middle, we have the line graph, which tells us about how each feature affects our final result. See, in the gender part, we can see 0.14 in no risk part, which means that females are less likely to get mental health issues. On the other hand, the one not having a brain defect are less likely to get depressed. Now, for a single data point, this might be a bit confusing. Let us look at the overall picture using our shape approach. Now, here are the 2 shape plots. The first shape plot conveys that relationship with lost one affects mental health very heavily. Same goes with gender and BMI ratio. While for sleep time it is negative, which means that higher the sleep time, lower the mental health risk. Same goes for education, screen time, lost someone and having friends. Now, the second plot is the most important, which is also called the bee swarm plot. Here we can see that blue means low and pink means high. I want you to recall that we have encoded data points into numeric values, with female getting 0 for gender and male getting 1 for gender. So, from the graph we can say that females are less likely to get depressed as compared to males. The second factor, which in the first graph we saw was heavily impacting our final result, is relation with lost one. If a person has not lost someone, that they are less likely to get mental health issues. But if they have lost someone which they were very close with, then they are more likely to get mental health issues. Now let us jump on to the sleep part. Here, the purple part lies in the no risk region. This conveys that a person getting adequate amount of sleep, that is not so high and not so low, are less likely to get mental health issues as compared to the one getting too much sleep or too less. Similarly, you can look for other features also. Now, here comes the conclusion. We have used machine learning to enhance the mental health predictions and XAI techniques to obtain the features which are affecting the mental health of a person the highest. Now, let us talk about the future work. There's an exciting concept called federated learning that can further enhance mental health applications. Federated learning is a decentralized approach where models are trained across multiple devices or institutes without sharing the sensitive data. This ensures patient privacy while still harnessing insights from diverse and comprehensive dataset. By combining XAI with FL, we can create predictive models that are both transparent and secure, empowering doctors to make better decisions without compromising confidentiality. Now, let us talk about limitations. As you guys have already seen, the accuracy of all our models was not above 0.8. point 0.8. This is because of the reason that the dataset we got from Kaggle was not so large. And the second limitation is scaling problem with Chef because of its computational complexity. Now, these are some of the references that you can go through to create your own XAI model. Thank you.